on engineering mathematics 4. The last class we have seen that are the basic four standard types, and also we have considered one idea. Suppose some equations, some PDEs are not in the standard form, but they can be converted into standard form with the help of some suitable substitutions here. What type of equations you are going to consider here? X gets power, Z gets power, P power 1 and Q power 1 type of thing. Similarly, Y gets power. That type of equation you can put substitution like here. If m not equal to 1, x power 1 minus m, capital Y, you are converting all the three. If all the three gets power here, x gets power, y gets power, z gets power here, then you can put all the small capital letters here. Correspondingly, we can get capital P and capital Q here. Capital P, capital Q. That can be converted, depends upon the condition. Suppose z only gets power, you can get substitution only for z here. Z here. Similarly, correspondingly, a change in the z only present here. Remaining things are as usual here, or you can convert like this here. And another one is that suppose x and y only gets power, but z there is no power here. You can put substitution only for x and y here. X and y type of thing we can consider. Now, based on this idea, we can see some problems here. This idea, you can see some problems. We require P power 1 and Q power 1 only. Okay, P power 1 and Q power 1 only. Solve P square x plus Q square y. P square Q square y is equal to z here. P square x plus Q square y is equal to z here. But instead of P power 1, that type of relation here P square and Q square, that type of idea we are getting here. So in the solution, given equation, given PDE, given equation becomes P square by z and Q square y by z. Okay, Q square z is equal to 1 here. 1. We divide by so on here. Divide by so on. And then you can get it as P square z power minus 1 x, and similarly Q square z power minus 1 y equal to 1 here. But we require x gets power, z gets power, okay, x, y gets power, z power, but P power 1 only we require here. Therefore, in that case, you would write P z power minus 1 by 2. Okay? Z power minus 1 by 2 and x power 1 by 2 power 2. Power 2. You can write like this here. P z power minus 1 by 2, x power 1 by 2 square here. Similarly, here Q z power minus 1 by 2 power 1 by 2 square here. We call 1 by 2 square. That is equal to 1. That is equal to 1. Therefore, in that manner, you can write that here. Therefore, here x gets power, z gets power, y gets power, z gets power. In the problem, x power m, z power kp, y power n, z power kp, q. That type of idea you can get that here. But we need a p power and q power 1 only. Therefore, p we must have that. But common power is applicable here. It is function of only. Therefore, you can use common power here. Therefore, is of the form f of x power m z power kp, y power n z power kq is equal to 0. Y power n z power kq is equal to 0. That type of idea you can get. Implies what about m here? M is equal to 1 by 2. 1 by 2 x power z power k. M n is also 1 by 2. N is also 2, but k is minus 1 by 2 here. Minus 1 by 2. If m is not equal to 1, m is not equal to 1, you can put implies you can put the substitution as x is equal to x power 1 minus m here. X power 1 minus m. If m is not equal to 1, you see that here. If m is not equal to 1, you can use x power 1 minus m. M equal to 1 log x here. That you can use here. Therefore, you can get it as x power 1 minus 1 by 2. I can get it as 1 by 2, x power 1 by 2. Therefore, capital X is to 1 by x power small x power 1 by 2 here. Small x. Similarly, because of n is not equal to capital Y. Capital Y is equal to, it is also y 1 minus n. Capital Y is equal to y power 1 minus 1 by 2, y power 1 by 2. Capital Y is equal to so on. Capital X, now capital Y. And capital Z, or Z is also k is not equal to minus 1. K is not equal to minus 1. You can put 1 plus k. 1 plus k. K is not equal to minus 1. I can put 1 z power 1 plus k. That type of idea we can follow. Z power 1 plus k. And capital Z is equal to z power 1 plus k. Z power 1 plus k. 1 plus what is k? K is minus 1 by 2. Minus 1 by 4 z power 1 by 2. Capital Z is also 1 by z power 1 by 2. That is, we have capital X is equal to x power 1 by 2. Y is equal to y power 1 by 2. Capital Z equal to z power 1. Correspondingly, you identify dou x by dou x. 1 by 2 x power minus 1 by 2. Dou y by dou y. 1 by 2 y power minus 1 by 2. Dou z by dou small z. 1 to z power minus 1 by 2. Z power minus 1 by 2. That relation you can get that here. Therefore, now capital P, capital Q, that you have to write here. Capital P is equal to, because everything gets changes here. X gets changed, Y gets changed, Z gets also changed here. Therefore, capital dou capital Z by dou capital X. But will be written in the convenient manner as dou small z. With respect to small z possible. Small z with respect to small x is standard notation, that is possible. Small x with the capital X is possible. Small x with capital X is possible. Therefore, dou capital Z by dou capital X is not directly possible, but Z with respect to small z possible. Small z with respect to small x possible, and small x with respect to capital X possible. Therefore, you can move indirectly. Therefore, dou capital Z by dou small z, it is 1 by 2 Z power minus 1 by 2. This is standard notation P. This is standard notation P. Dou x by dou capital X. This is reverse reciprocal of this one here. Therefore, we can get it as 2 reciprocal of this one here. Therefore, we can get it as x power 1 by 2. 2x power 1 by 2 reciprocal of this one. Therefore, we can get it as 2 get cancelled here. 2 get cancelled here. For this capital P can be written as implies capital P is nothing but, what is capital P? P z power minus of x power of P. Capital P can be written as P is minus of z power minus of x power of. This is the expression we require here. You see that here, P, small p, z power minus of x power of. Small p, z power minus of x power. Yes, this can be now written as capital P converted here. We'll take it as equation number 1. Similarly, capital Q you have right here. Capital Q. Capital right. Capital Q is equal to S. Again, same. Everything gets changes here. Dou Z by dou Y. But Z by dou small z possible. Dou small z by dou small y possible. Dou small y by dou capital Y possible. Dou Z by dou Z is 1 by 2 Z power minus of 1 by 2 Z power minus of. This is Q, standard notation. Is reciprocal of this one here. Reciprocal of this one. Therefore, 1 by 2 will be 2 y power of 2 y power of. These 2 to get cancelled. Therefore, Q Z power minus of y power of, that is equal to capital Q. Capital Q. Now substitute capital P and capital Q in equation number 1. In equation number 1. This is a given equation. P z power minus half, this is capital P, this is now capital Q. Therefore, we can get capital P square plus capital Q square equal to 1. Therefore, this can be written as capital P square plus capital Q square equal to 1 is of the form capital F of PQ equal to 0. Okay. Standard type 1. Okay. Standard type 1. Form of type 1 equation. Type 1 equations. Capital P square, capital Q square equal to 1. So the solution, complete solution and everything. Therefore, complete solution of 1. Because capital F of PQ type 1 means what will be your complete solution, but you will write everything in terms of capital letters here. Capital AX, capital BY plus C, where A and B are related by K and B are related by capital F of AB equal to 0. What is capital F of PQ? A square plus B square. Or B can be written as plus or minus square root of A square. Therefore, B can be written like this. Therefore, complete solution is capital Z. Everything gets changes here. Capital X, capital B, capital Y, but B is plus or minus 1 minus A square, capital Y plus C. Therefore, complete solution of equation number 1. Solution of equation number 1 is capital Z is what in terms of small letter here. Capital Z is y power 1 by 2, capital Y is y power 1 by 2 in terms of small letters here. Original equation equal to root Z equal to A root X plus or minus root Y plus C. Root Y plus. This will be your complete solution of equation number 1 by substitution. And similar general solution you can write as usual. Singular solution is simple. General solution is your write A as a phi of A. Singular solution is impossible. And general solution is obtained by putting B equal to pi of A in general solution. Sorry, in complete solution. B equal to pi of A in the complete solution. This will be the idea we can follow. Idea is very simple. So you see that here it is not in the previous 4 types. For F of PQ, F of ZPQ, separable equation, F of ZPQ, and Clairaut's form here. But ZPQ means if you consider ZPQ form here, P square X and so on here. Y, X and Y is also present here. Therefore, not in the previous standard form here, but some power is present here. Therefore, can after dividing that we can get the common power. Then Z and X gets Z and Y gets the power here. Therefore, it is of the form F of X power M is K, Y power N is power KQ, and so on here. M of N K equal to minus half. We can get capital X is equal to X power 1 minus M, capital Y is equal to, and capital Z we can write here. For substitution, because all the variables gets power here, X, Y, Z. We can put the substitution like this here. Then you can write X, capital Y, capital Z here. Correspondingly, you find derivatives. Then what is capital P? Because everything gets power. Therefore, dou p capital Z by dou x here correspondingly you write based on the given relationship. Therefore, we are getting P, capital P, the required expression of the given equation. Well, capital Q is equal to required expression of the given equation. Substitute these two in one. Therefore, it becomes a standard type form here. So, f of p equal to 0. Type 1 equations. If it is type 1, you can write easily the general solution. But everything gets changes here. Z, X, Y. So we have to put all the variables get changed here for PQ. Then everything. Then finally replace capital S, capital X, capital Y comes a small letters. That will be the solution of the given differential equation.
Sir,
Well, if you
here putting
understand this
C equals to phi of A, sir. Last slide.
last slide, this one or previous one?
This one, sir. C equal to phi of A.
Uh, C is equal to pi of no C. No, C. C is equal to pi of C is equal to pi of A in the complete solution. We need two arbitrary constants. Already A changed here. B changed here. Okay. Right. All of you understand the idea? Similarly, you have another problem that if you want to get another one, suppose if you want to get a log x, that type of idea. X square p not x square pq xy, that is pq x pq xy is equal to z square. Pq xy is equal to z square. Okay. Pq xy equal to z square. If you want to consider this problem here, you can club px and after dividing by z square here. After dividing by given PDE can be written as you have to club x and qy, that type of relation here. Therefore, px px and then qy equal to z square, divide by z square, then px by z 1 and qy by z 1 z, one more z, then you can get 1 here. Or divide by z square means put 1 z here, 1 z here, then you can get this relation here. In by you can write it as xp z power minus 1, okay, z power minus 1, and similarly yq z minus 1 equal to 1, okay, z power minus 1, xp z minus 1, yq z power. This is the given equation. Okay, given equation. This of the f of x power m is power k p y power n z power k q is equal to 0. What about m? M is 1, 1. P power 1, yes, p power 1, q power 1. N is also 1. K is also minus 1. K is minus 1. Oh. Where m is n is 1, k is minus 1. Z power k. Z power k, k is minus 1. What about your substitution? M n k is present. Can anyone give the answer for the substitution, possible substitution? Capital X is equal to?
Log E.
If m is equal
Log X.
log x. Capital Y is
log
also
y,
log Y. Capital Z is
log z,
log Z. So dou capital X by dou X is 1 by X. Capital Y by dou small y is 1 by Y. And capital Z by dou small z equal to 1 by Z. 1 by Z. These are the substitutions you can get that. Therefore, capital P is everything get changed here. Dou capital Z by dou capital Z X. Dou Z is possible. Dou Z by dou X is possible. X is possible. Dou small x by dou capital X is possible. Dou Z by dou Z 1 by Z. This is P. This is reciprocal of this one X. For XP Z power minus 1 is capital P. Similarly, capital Q. Dou Z by dou capital Y. Dou Z by dou small possible. Dou small z by dou X possible. Dou X by dou Y possible. And dou Y by dou capital Y possible. Because you are moving for Y. So dou small z by dou small y possible. Dou small y by capital Y possible. This is 1 by Z. This is reciprocal of this one Y. Y Q Z power minus 1, capital Q. Capital Q is YQ Z power minus 1. Okay? Then you see that here XP Z power minus 1, YQ Z power minus 1, that is equal to 1. That's the equation. Therefore, substitute here. Substitute equation number 1. What you can get here? P is equal to 1. P is equal to 1 of the form of capital F of PQ equal to 0, type 1. For complete solution is ever capital letter where A and B are related by F of A B equal to 0. That is A B equal to 1, B equal to A. For complete solution, B is 1 by A, capital letter. Complete solution of 1 means capital X is log X, is log Y, capital Z is log Z, small letters here. Put X is equal to log X, Y is equal to log Y, and Z is equal to log Z. Then complete solution of 1. Log Z equal to A log X plus 1 by A log Y plus C. General solution is put obtained by C is equal to pi r. C is equal to pi r. No singular solution. No singular solution. Okay?
oh,
Very simple procedure. You have to write the equation with P1 Q power 1. That is very important. Remaining gets power, no problem. Z also you have to get common power only. Both term Z also you have to get common power. Then put corresponding substitutions here, suitable substitutions here. Convert it into standard type. All of you understand here. Idea is very simple only. Can you give the answer for this one here? Third one, the same procedure. X square by P, y square by Q is equal to Z. Can you proceed further like this, like a previous problem? P power 1, Q power 1, that is very important. Common power is okay, but when you club with XP, YQ, Z, XP, Z, YQ, Z, you have to get power P power 1, Q power 1, but common power is okay. Common power. What type of conversion we can follow here? Square P power minus 1, Z power minus 1. Equal to 1 divided by Z. But P power 1, Q power 1, that is very important. Therefore, how can you P Z power minus 1? Y power minus 2, Q Z power minus 1. Equal to 1. For M minus 2, N minus 2, K 1. We proceed further. What will be converted equation? You tell that.
Z square equal to ax cube plus
Z
ax
square equal
cube
to A
x cube
plus
plus 6a by 3 into 3a minus 2.
3A minus 2.
Sir, 6 into a by 3 into, not 3a minus 2, sir. 6 into a.
6 into
A by
A by
3 into
3 into
3a minus 2 brackets.
minus 2 denominator.
3a minus 2, yes, sir.
3A minus 2 in the denominator.
Yes, sir. Y cube
into
plus
Y cube.
pi of a. Yes.
Yeah, general source. Okay, Z square equal to AX cube and so on into Y cube plus pi f. Okay. Before we can proceed this here. Oh, this will be the idea I can get. Simple procedure only. Fourth one, we take another problem there. Z power 4Q square minus Z square P. Z power 4Q square minus Z square P to 1. Minus Z square P is equal to 1. It is of the form Z power Kp. Z power Kp, Z power Kq. That type of idea. That type of idea. Power, some power is present here. Power relation is present. Given PDE can be written as some Z power K P power 1 we require. Similarly, Q power 1 is also we require here. Therefore, this can be as Z square Q. Z square Q. Z power 4 Q square you can get here. Then Z square P here there is no change. No change of the form f of z power k p, comma z power k q is equal to 0. There is no x and y. Okay? There is no x y. X y is separated one. Here there obviously there's no x y here. Okay? Therefore can this here. But z only gets power. There is no x y here. Therefore where k equal to 2. Okay? K equal to 2. Therefore you can put the substitution z equal to z power 1 plus k. Okay? Z power 1 plus k. Z power 3. Z power 3. So dou capital Z by dou small z equal to 3 z 3 z square. Based on this idea, z only gets power, z only get changes here. Capital P can be written as z only get change. No x, there's no change in the x. There's no change in the x. Therefore, you can write capital P as a dou capital Z. Z comes as a capital Z. There's no change in the x. No change in the x. And how can you convert this one? Dou capital Z by dou small z possible. But dou small z by dou small x is a possible here. This is notation. For dou capital Z by dou small z is 3z square. 3z square. 3z square. And this is p. This is p, the standard notation. For z square, p can be written as p by 3. Equal to p by 3. P by 3. Similarly, q, capital Q. Z gets changes, but y there is no change. Dou z by dou small z possible. Dou small z, dou small y, standard notation. This is dou capital Z by small z is here 3z square. This is q. Okay, this is standard notation q. But we need z square q here. Z square q. Equation number 1. Implies z square q is equal to q by 3. Q by 3. Z square p by 3. Z square q is equal to q by 3, capital letter here. Therefore, substitute in equation 1. In equation number 1, implies what you can p by 3 minus q by 3 whole square. Q by 3 whole square is first, minus p by 3 minus p by 3 is square base 1 equal to 1. That is q square, this is 9 minus 3p is equal to 9. 9. Of the form f pq is equal to 0. Therefore, complete solution. Capital Z get changes, but x and y there is no change. X and y there is no change. You have to use small x small y only. Small x small y, where a and b are separated by f of ab equal to 0. That's equal to b square minus 3a equal to 9. B equal to plus or minus 9 plus 3a. No, plus or minus 9 plus 3a. Or we can write a as in terms of b. Any manner you can write, no problem. Implies complete solution of equation 1 is by putting capital Z is what here? Capital Z is Z cube, small z cube. By putting capital Z equal to Z cube. That is capital Z is Z cube, A small x, B is plus or minus 9 plus 3A, small y plus C. ax plus or minus 9 plus 3a plus pi of t. Here in this problem, z and p, zp, zq with the power is there here, z power kp, z power kq form here, p power 1, q power 1, that is very necessary. Depends upon that you raise the common power. Okay? Now, z only gets changes, but x and y no changes here. Therefore, depends upon that you write capital P, capital Q. Okay? Capital P, capital Q. Then substitute, you can get the answer. Okay? You can get the answer. Another problem here. Solve p square plus square. Okay? P square plus q square equal to z square into x square plus y square. P square plus q square equal to z square into x square plus y square. X square plus y square. The same idea. Z divide by z can get z square, sorry, p by z whole square divide by z, and q by z whole square equal to x square plus y square. But z and p with the power, z and q with the power x square plus y square. Z power k, z power kq, but x and y not with the pq, not with the pq. X and y is a separate one. With the pq only is that. With the pq is that only with the power. So with power. Yes, of the f of z power kp, z power kq, x and y separate one. Okay, x and y separate. But z only with the p, only with the q, with the power here. But k equal to minus, k equal to minus 1. So k equal to minus 1. Therefore, capital Z equal to log Z. K equal to minus 1 means log Z. Rho capital Z by rho small z to 1 by z. Capital Q is equal to dou capital Z by dou small x. X and y no changes. X and y no changes. This is 1 by z small p. Capital P is equal to what? Z power minus 1 p. Z power minus 1 p. Yes, Z power minus 1 p. Similarly, Q, no change. Is that possible? With respect to y possible. This is 1 by z. This is standard notation q. Z power minus 1 q, capital Q. Capital Q. Now substitute in equation number 1. What is 1? 1 is this is capital P. This is capital Q. Capital Q. P square plus Q square equal to x square plus y square. P square plus Q square equal to x square y square. Can anyone give that? What is the standard form here?
F of px equal to g of qy.
Okay. F of x comma p is equal to y comma p. Standard form of separable equation. Okay. Separable equation f of xp equal to g of y. G of y. That is q plug p square and q square p square minus x square equal to y square minus q square equal to sum a, say p square minus y square equal to some a square. So for convenience you take a square, y square minus q square equal to a square, as inside square is there, a plus x square, a square plus x square. Q is y square minus a square, no, y square minus a square. For p is equal to square root of, we take positive, q is also square root of y square minus a square. By total derivative idea, capital Z only get changes here, therefore capital PDX, capital QDY plus C. Plus C. For this one, it is x square plus a square formula. X square plus a square for x by 2 square root of x square plus a square plus a square by 2 sin h x by a. That similarly y square minus a square. That's also you can write like this, but cos h inverse of y by a. We can write this. First one is capital Z, capital Z, x by 2 square root of square plus a square by 2 sin h inverse of x by a plus, this is first one, or y square minus a square, square root of y square minus a square, y by 2 square root of y square minus a square plus a square by 2 cos h inverse. You can use logarithm of so on, cos h inverse or logarithm. Yes, laptop power shutdown. Sorry for interruption. Yes, column ends with y by 2 square root of y square minus a square by cos h inverse of y by a. No, y by a. By 2 and minus a square by 2 cos h inverse of y by a plus c. Input z equal to log z here. I think that log z. What about z substitution? Log z. No, log z. Log z equal to the same thing. Is the complete solution. Log z equal to the same thing is the complete solution. Singular and general solution can be found as usual for this type because it is separable. Singular solution is impossible. General solution is put c is equal to pi of to I of A that you can write here. That will be the idea. And here the last two problems Z only gets power. Okay, Z only gets power with the Q. Z only gets power with the P and the Q. X and Y separate one. Okay, X and Y. So Z only gets power means give changes to Z only. There's no change in X and Y. There's no change in X and Y. But obviously it becomes a separable equation form here. X power comma P is equal to Y comma Q. And that type of idea we can follow here. Then you can use separable equation procedure, and then you can get the solution. That will be the idea we can follow. Similarly, suppose xp and q, but z is separate one. That is, but otherwise there is no z is present. You give y only changes here. There is no change in the term here. In that manner we can proceed. Similarly, one problem for your exercise. Z square into p square plus pq square equal to x plus y equal to x square plus y square. The same procedure. Previous problem. Z square into p square equal to x square plus y square. Z into p square plus q square equal to x square plus. That is exercise sum for you. Okay? All of you try on this problem here, and we'll see some more idea in the next class. Okay? Tomorrow class will. Okay? This is the procedure of equation converted into standard form. Okay? Can be converted into standard form. Either with p or x power with p, y power with p, or x z p, y z with p. That is type of things you have to y z with q. That type of thing you have to follow. Right. That's all. If you have any doubt, ask. Thanks for attending this session.